We're seeing a universe we've never seen before. We thought it was there, we hoped it was there, but now we see it for the first time.
This is strange. The sheer amount of perfection found within it is incredibly mind-boggling and totally questionable given the immense randomness that was present in its formation mechanism. The presence of a single element would determine the existence of another, which determines the existence of another, that will determine the existence of millions more. And the culmination of a particular individual process has to come out just right for another process to even take place. It sounds almost as if it's destiny. Imagine an artist attempting to paint the perfect masterpiece on an expansive canvas. Each stroke of the brush, each careful selection of colors and techniques, every tiny detail just right, blending seamlessly to the harmony of shapes and forms. Every aspect of the painting to achieve the perfect composition, a masterpiece that captivates and astounds viewers. Too much of a single color, too much of a single stroke of the brush, then the perfect masterpiece ceases to exist. Our universe showcases a strange amount of perfection, almost as if it were designed just for us, from the tiniest particles of the quantum realm to the largest cosmic structures housed in our universe. There exists an underlying harmony which allows for the continued sustainability of the universe. Existence of planets with the right distance from their sun, presence of liquid water and perfect atmospheric conditions to host the development of life. This observed precision has baffled scientists for centuries, if not millennia. Why does the universe appear to be designed solely for the existence of human life? Is this strange perfection a result of chance or fine-tuning? Is there something else we don't know about? Well, we are about to find out. If we want to discuss the strange perfection in the universe, we can't completely do that without mentioning the concept of fine-tuning. Before we begin, let's do a little something. Pick a number, any number between 1 and 1,000,000. I'll pick mine too. At the end of this, we'll reveal our numbers. Imagine, if you will, if a lot of things in the universe were not perfect. What if the force that holds atomic nuclei together was just a bit stronger? Our sun would have burned out in an instant, and life on Earth wouldn't exist. Conversely, if the weak nuclear force were a little weaker, the essential elements of our world wouldn't exist, and neither would we. If gravity were slightly weaker, it couldn't have ignited the sun's nuclear reactions to create sunlight. If it were stronger, the sun would have exhausted its fuel long ago. These are just a few examples of how the laws of physics appear finely tuned. Many fundamental aspects of nature, such as the strengths of forces and the masses of particles, seem perfectly adjusted for life to exist. It's as though the universe was designed for us. Do all of these mean that we are special, or are we just lucky? What does it mean for something to be finely tuned? So back to the numbers. What was the number you picked? Go ahead and write that down in the comments. Well, my number was 1,234. So, what are the chances that you luckily picked the same number as I did? That will be 1 in 1,000,000 chances, right? And this could only happen if you could somehow read minds or you somehow watched the video before it was published. So you'd agree that if you were to pick the same number as mine 6 times in a row, you'd need some kind of strategy to accurately give you the right combinations to arrive at the same numbers I would pick. All right, in that same view, picture our universe, almost completely perfect. Designed with the right combinations of elements, forces, and processes responsible for the formation of the tiniest quarks to the clusters of galaxies in the cosmos. That's what we could call fine-tuning, and it's precisely the same fine-tuning that exists in the universe. Considering all the possibilities are extremely tiny, it's possible that the universe was naturally born with this perfect balance between its contents and initial expansion rate. It's possible that it has always been this way. However, in science, when we encounter a seemingly unexplained coincidence, it's not enough to simply assume it's due to initial conditions. From a scientific perspective, it's better to try to find a reason for why this coincidence might exist. One possible explanation is to suggest that there are countless different outcomes and universes out there. We just happen to exist in a universe where our existence is possible, which is why everything seems perfectly tuned for us. It might be true that the universe could have been anyway, and we happen to live in one where things are as they are. However, relying on this idea called the anthropic principle doesn't provide us with a scientific solution. It's like saying we've given up on finding a real scientific answer to the puzzle. We'll get back to this anthropic principle later in the video. However, a solid scientific argument should do two key things: explain how these seemingly finely tuned conditions come about and make specific testable predictions that are different from what we'd expect without that explanation. The second point is what sets a scientific argument apart from a non-scientific one. If you can only rely on the starting conditions of a problem, you won't have a way to test your scenario further. While other universes might exist, if we can't observe them and determine if they share the same initial conditions as ours, it lacks scientific value. On the other hand, if a prior phase of the universe created these initial conditions while also making additional testable predictions, that would be of great scientific significance. When we consider the energy balance of the universe, where the expansion rate seems to align perfectly with the total energy, a theory like cosmic inflation is a strong contender. Inflation could stretch the universe flat, creating the right energy balance for the expansion rate. When inflation eventually stopped, it set up the initial conditions for the Big Bang. Moreover, inflation also makes extra predictions that we can test through experiments or observations, providing the scientific rigor we need. Many fundamental constants have values that seem just right for life to exist. In 2000, astronomer Royal Martin Rees condensed these cosmic constants into 6 numbers in his book. The first number, denoted as n, signifies the ratio between fundamental forces, specifically the electrostatic and gravitational forces between protons. This value, 10^36, defines the minimum size a star can be, determining if gravity can overcome electromagnetic forces for nuclear fusion. If it were smaller, stars would be reduced in size and burn fuel faster, potentially impacting the likelihood of life evolving. The second number, epsilon, symbolized as E, represents the proportion of a hydrogen atom's mass converted into energy during fusion into helium. With a value of 0.007, its precise value enables the creation of heavier elements and complex chemistry vital for life. A slightly different value would hinder or exhaust the universe's hydrogen, affecting star formation or leaving only hydrogen post-Big Bang. Moving to the third number, omega, symbolized as O, it indicates the ratio of the universe's matter density to a critical density. At around 0.3, omega determines the universe's expansion rate, preventing collapse or excessively rapid expansion, both unsuitable for star and galaxy formation. The fourth number, lambda, representing the cosmological constant at roughly 0.68, influences the universe's accelerated expansion. If significantly larger, it would accelerate expansion excessively, impeding star and galaxy formation. The fifth number, Q, approximated at 10^5, measures energy required to disintegrate a galactic supercluster versus its total stored energy. Changes in Q's value would drastically affect the universe's structure, potentially leading to motionless states or dominance by black holes, unsuitable for life support. Lastly, the sixth number, D, stands for the spatial dimensions we inhabit, valued at 3. This three-dimensional universe allows stable orbits and the potential for life. Altered spatial dimensions would render stable orbits impossible or life untenable. These 6 numbers collectively illustrate finely tuned conditions necessary for our universe to support life. Their precise values raise profound questions about the universe's nature, whether it's meticulously designed for life or governed by deeper, undiscovered physical principles, sparking inquiries into the anthropic principle. Space-time undergoes expansion or contraction, curving based on the matter and energy contained within it. Particles attract, repel, or bind together depending on the conditions under which they interact. Stability or decay of systems over time is determined by these processes. While the scientific process explains how these events occur, it does not always delve into why or if they were predetermined. In the exploration of the universe, a guiding principle becomes crucial when faced with challenges. For an extended period, we've known about the diverse elements within the universe, with at least 59 elements found in the human body. Initially, the complete understanding of how these elements were formed remained elusive. Yet, it has always been evident that our existence is tied to observing and exploring the universe. This straightforward fact carries profound significance, implying that our universe is structured to allow the evolution of intelligent observers like us. The anthropic principle stems from this notion and imparts valuable insights. Proposed by physicist Brandon Carter, the anthropic principle suggests that the apparent fine-tuning of the universe's physical constants and conditions for intelligent life can be comprehended because we can only observe a universe conducive to our existence. The anthropic principle comes in two main types: the weak anthropic principle and the strong anthropic principle. The weak anthropic principle argues that the universe must permit the existence of intelligent observers, as otherwise, we wouldn't be here to observe it. Conversely, the strong anthropic principle suggests that the universe is precisely fine-tuned for the existence of intelligent life, implying intentional design or creation. An early application of the anthropic principle occurred in the 1950s when scientist Fred Hoyle utilized it to predict an undiscovered excited state of carbon-12, crucial for the formation of heavier elements. This audacious prediction turned out to be correct, elucidating the origin of all heavy elements in the universe. While the anthropic principle guides understanding of why the universe's properties must fall within certain ranges for life to exist, it does not provide a comprehensive scientific answer to all questions. Uncovering the underlying dynamics and exploring how and why the universe developed as it did remains essential for genuine scientific progress. The pursuit of knowledge and more comprehensive answers continues. As we keep exploring the universe, our research reveals a complex interplay of forces and constants. Meanwhile, the anthropic principle suggests fine-tuning stems from our observational constraints. Historical applications, like the ones of Fred Hoyle's, highlight its utility, but it alone falls short of a complete scientific answer. True progress requires a deeper understanding beyond the anthropic principle, urging exploration of fundamental forces, constants, and cosmic dynamics that drives our universe's continuity. Alright, this is where I will end this video. Like, subscribe, share your thoughts down in the comments, and I'll see you in the next video.